Hey everyone, I'm Lucas, a current AP Calculus BC student who makes these videos to help myself study. So today we're going to be doing the derivative of the natural log, or ln x. Alright, so let's get into it. So the derivative of so we have derivative of ln x equals 1 over x. Pretty simple, right? So what if we have a function right here instead of just x? Well, we're going to have d over dx ln u equals u prime over u, right? So let's move these right here. Oh wait, it's a little too far. It's okay. We don't need them. You guys are good at this. I know it. So we know those, but also let's freshen up on our log properties, right? So if you have ln a b, it's gonna be equal to ln a plus ln b. Then if you have ln a to the power of b, it's going to equal b ln a. Then if you have ln a over b, it's going to equal ln a minus ln b. So these are the properties right here. Remember these? These should be a review if you're doing calculus. These should be a review, but just in case you don't know them, here they are. These also work for logs as well. Okay, let's get into some problems. So if I have f of x equals ln 2x. Alright, so f prime of x. Let's do this. So u prime, so this right here is going to be u. So u prime, prime of 2 of x is just going to be 2 over then just u, 2x equals 1 over x. So it's basically the same as just ln x, but, you know, it's fine. So let's try another one. Let me get a problem. Let me get a good one. Alright, f of x equals ex ln x. So this is actually product rule. Oh, can't draw over there. Okay, this is product rule. Remember, the derivative of ex is just ex. So we're going to have ex times 1 over x plus ex uh, times, yeah, ln x. You could also do this the other way. Same thing, but, you know. Okay, so we know these both have e. Let's see what we can get. Let's see what we can get. So we multiply these. They so then we end up with ex over x plus ex ln over x, just like that. Now we want to get these over the same denominator, right? So how we're going to do that is we have this one, which is x. It's going to be pretty hard to get rid of this x, so let's multiply this, right? We'll put it over 1 times x over x. Now the reason that we can do this is because it's just over 1. Right? X over x is just 1, right? Like, it's just as simple as that. And you can do this for a bunch of other things as well. So, let's do that. So, I'll erase that. Right here, x. Here, let me erase this box. So once you multiply it by that, then you're also going to have an x right here. It'll be like this. Now once you do this, you can just add them. And so, you're going to be left with, here, I'll erase it from right here. You're going to be left with ex plus I'm moving the x over here, ln x all over x. Now, we're still not done. Alright, we're still not done. So, once we do this, let's take a look at this. Oh, forgot the x. Let's look at this. This term and this term, they both have something in common, and it's the ex. So let's just factor that out, right? So we're going to be left with 1. Oh, I'm sorry. No. So always let's do the ex, because we're factoring that out, parentheses, e times what equals ex, 1, plus e times what equals this. Well, it's going to be x ln x, then over x. And this is your answer. Pretty simple, right? So always try to factor something out. That's always going to be pretty helpful in almost all situations. But yeah. Also, when you're getting derivatives, you also want to try to make things like the same denominator. It makes it pretty easy, right? So yeah, that's just a simple lesson on natural logs. There will be a video coming out soon, maybe within a week or two, about implicit differentiation. That one's a little bit harder, so I want to kind of save that video. But yeah, that will be coming soon. So yeah, thank you for watching. Bye.